Hello everyone, good afternoon to all my dear bacha log. So tell me bacha log kaise hai sab? How are you all doing in this very fine afternoon? Okay, I'll be looking into the chat box to know how my bacha logs are doing. Okay, hi Yash, hi Sunita, good afternoon. Ayan, good afternoon. It's your birthday, Jasmine. Oh my goodness. So I should sing a song for you, right? A birthday song, everyone. Before we start with the session, let's have a small birthday song to our Nanna Sa Munna Sa Pyara Wala Jasmine ko. Everyone? Okay. 1, 2, 3, here we go. Happy birthday to you. Happy birthday to you. Happy birthday, dear Jasmine. Happy birthday to you. Okay, may you live a lot longer with full of happy and amazing moments in your life. Okay, so good afternoon to everyone. Jolsna, Nawal, Sachin, Ayan, Rashida. No. Lunch I'll be having some a bit time later. Okay, so yes, a big hi to every one of you once again. So in this particular session, what we are gonna do? We all know about the chapter thermodynamics, and we already know how important it is. We all have learned the concepts, right? Yes, we have. So in today's session, we'll be mainly discussing all the important questions from this particular chapter of thermodynamics, so that after the session you will be having no doubts related to this particular chapter, right? So I hope you all are ready for that. Before that, if anyone is thinking, who is this person? This is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Ameer Bhaiya, right? And here we are. More about me you can see on the screen here, and if you want to know more and more about me, come and join my classes all the time. We'll get to know more, right? Okay, moving on. If you don't want to miss any of the updates from the YouTube, right, you can be a part of the Telegram channel. The link is given here and in the description box. Okay. Now, Bugs Bounty, it's an amazing program which can help you to grab a lot many prizes. What do you all have to do? You just have to go to the description, find the form, fill the form. If you are finding any inappropriate content in the videos uploaded by Unacademy, if it is valid, है ना बच्चा लोग बहुत सारा खूब सारा okay खूब सारा prizes मिल जाएगा for every one of you. So don't miss this opportunity. So keep on filling the forms. Okay. Now. Who are not yet a part of the Unacademy Plus subscription platform or the Iconic subscription platform, I'll tell you what all amazing features you are or you were missing till now. If you're a part of Unacademy Plus subscription, you can be a part of all the live classes that happens there. More than that, weekly tests will be happening, and you will be having a structured course which will help you to prepare for all your examination in a structured and well-defined manner. That itself is more than enough to help you grab lot many marks and good ranks for all the competitive examinations, right? Okay. Now, if you go for Iconic, you will get all the features of Plus subscription, plus some extra features such as a personal mentor will be there. Personal mentor matlab a person will be assigned to you. Okay, he'll be looking after all the academic activities, planning of all the academic activities for you. So you just want to sit there, he'll be telling you what you have to study in this particular day. You just want to learn that, complete whatever is being assigned to you, right? And be happy, that's all you want to do. ठीक है, so you don't have to think about आज क्या करना है, आज कितना करना है, वो करना है, ये करना है, कुछ भी नहीं, right? Do what you're supposed to do by this particular person. आराम से जिंदगी जीना. Then live doubt solving classes will be there specially for you. Weekly reports will be given to you. मतलब everything will be there, right? To upgrade you and to improve your studies in every possible way. Now, if you go for Plus subscription for 12 months, देख ले, it should cost you actually 1,250 per month. Now, if you can use Hamara code, what's our code? The entire code for our physics family, which is AMB10, you'll get extra 10% of discount and obviously maximum offers with which you can enjoy your life. Okay, now Iconic subscription for 12 months, it should cost you 2,333 per month, but we have our code मेरा बच्चा लोग AMB10, ठीक है, use कर ले 10% discount ले ले, enjoy and have an amazing life. So if you have any doubts related to anything related to Unacademy, you can just be in touch with our counselor. The number for calling this person is right here, so don't misuse it. Okay, only whenever it is being required, use it. Fine. Okay, moving on. Dekhli, open house sessions always happen. This will help you to get more in touch with the teachers. Don't miss any of the open houses. Okay, fine. Now We all know offers are going on only for the first 500 subscriptions. For the, if you go for 3 months or more than that subscription, extra 1 month will be given free. Wow, but chalo wow. So amazing things are happening. Okay, so try to be a part of those amazing things. What is happening here in Unacademy? Okay. Now tell me, are you all ready for the session? Are you all ready for the session, मेरे बच्चे लोग? That's all I want to ask you right now. Are you all ready for that? आपका एग्जाम है कल, अरे what do you say? Best of luck. Okay, do well. Go for the examination all with a smiling face. Write everything, okay, in the right way and come out with that smiling face. Okay, just rock your exam. That's what I say. Ayan, yes. Sumit's ready. Jasmine, yes. Everyone with full of energy. दिखा मुझे पूरा energy दिखा. Yes, sir. We are good to go. Give me that wall energy. That much. That much should be there in your voice. Which iPhone? It's not an iPhone here. I just made a sticker there. वही है. Everyone ready? है ना? पूरा का पूरा. Yes, here we go with the very first question. What is thermal equilibrium? Okay. When can we say that two systems are in thermal equilibrium? Go for it. Let me see how many of you have got this idea. It's a very simple thing. Anyone? Anyone already gave me the answer or what? Many are going for the options D here. Hi Meru. Okay, C, D. I'm getting a mix of options, right? Ayan is going for D, Sumit is going for D, Shreya is going for D. Parni, D. Okay, D. What is thermal equilibrium? I'll explain you. We have two systems, okay? We have a system A and a system B. Let's say this system is having a temperature of TA and the other system is having a temperature of TB. We will say these two systems are in equilibrium. We'll say these two systems are in equilibrium when the temperature of the first body and the temperature of the second body should be equal to each other and pressure of both the bodies should be remaining as a constant. It is not necessary that pressure and volume of both the systems should be equal. It should be remaining as a constant. Matlab it shouldn't be changing further. Okay, it should be remaining as a constant, but the temperature of both the bodies has to be remaining equal. Then we will say that it's in thermal equilibrium. So which option we will go for? We will go with the option C. When two objects in contact with each other are at the same temperature and a constant value of pressure and volume. It is not necessary that pressure has to be the same, right? Pressure needs to be a constant value. Volume needs to be a constant value. It shouldn't be changing further. समझ में आ गया? ठीक है? Fine. That's all. So the correct option is option C, which says that both of them should be at the same temperature. So option C is our correct answer. मिल गया सबको? Is it clear? Everyone? Okay, so I hope you understood why we don't go with the option which one, D here, right? The more precise answer is option C. Option B also, let's say even both are having the same temperature, we can call it as a thermal equilibrium, right? But it is not a necessary condition. Okay, pressure of the body A and pressure of the body B, it is not necessary for both of them to be equal. That's what I say. If it is equal also, ठीक है, but it's not as a necessary condition. Necessary condition is ये, temperature should be equal. समझ में आ गया? ठीक है? Let's move to the next question. जाओ bye. अगले. Okay. Next question from first law of thermodynamics. Everyone, अच्छे से कर ले. Everyone. Yes. Okay, I can see lot many yeses there. Questions? हाँ, questions तो आ गया. ठीक है, अभी करने का वक्त आ गया. So करके दिखा. Waiting for answers. अरे, you need what's it? Small milliseconds for doing these kind of problems. Nannu Munnu. Who gave answers to Nannu Munnu questions? Who gave answers? Zahik is going for option D there. Then Shirvari is going for 200 joules. Is there? Okay, option B. Okay, Sumit is going for option D. Hardik is going for option D. Dekh lega. Okay, let's see what is the correct answer. Ready, everyone? The heat exchanged between the system and surroundings value is given along with the sign, that is plus 60 joules. Delta Q ka value is given as plus 60 joules. Okay. And the internal energy change is minus 180 joules. ठीक है. Delta U ka value minus 180 joules. Sign is given. So doing this problem is not at all a difficult task. Work that. How will we solve this? Array, most of the numerical question that appears from the chapter of thermodynamics is based on which one? First law of thermodynamics, delta Q is equal to delta U plus work done. We know this. Two values are given, third value can be found out. Just substitute the values. 60 is equal to minus 180 plus work done. Work done is equal to minus 180 goes to the left hand side as plus 180 plus 60 is 240 joules. So work done is how much? 240 joules. So option D is a correct answer. Have a look at everything. I don't think there is any step which can bring confusion to anyone here in this class, but still have a look at it. Jaldi se copy down kar le, or those who are slow hai na, or those who want to write down the answers later, you can take a screenshot. I think taking screenshot from YouTube is possible. Hai na? How to prepare for term 2 for 11th? At the end of the class, I'll give you a lecture, right? If you are still there at the end of the class after completing all the 25 questions in today's class, if you're still there, if you still have that doubt, I'll be clearing it to you. Okay, right now we'll focus mainly on what? Okay, I think Ayan, Kapil, Dhruvit, Karthikeya, everyone gave me the answers. I'm so happy. All good. Super great. Yes, yes, yes. Ready for the next question? Banchalu, right? Okay, I'm just, I really want to do maximum number of problems here in this class within this 2 hours, right? Don't think the sir is in jaldibazi, he just want to get out of the class. No, I'll be here for 2 hours, right? So I just want to do maximum number of questions within that 2 hours. ठीक है? अगला question. So if you want to do maximum number of problems, how many of you want to do maximum number of problems? बहुत सारा problems कितना? How many of you want to know? Many of you, right? So jaldi se jaldi, everyone be active, try solving all the problems as fast as possible. Okay, so question is here. Go through the question jaldi se and give me the answers here in the chat box. Crystal clear dark web. Okay, Rukshar. Great, great, great. So once you get an answer, you can start posting it here. Okay, Maru is going for option C. Nothing is going for A. Dark web is B. Okay, Sumit is going for C. Okay, everyone is having their own options. Those who are still doing, keep on doing it. Okay, and those who want to listen, can listen to me. What is the answer for this? Like, a system goes from the state A to the state B. System is moving from the state A to B and it is supplied with 400 joules of heat. Matlab delta Q ka value 400 hai. Now my question, is it positive value or negative value? Positive value. Q. Why delta Q has to be positive? Because it is given that we are giving heat energy to the system. Heat energy given to the system, positive. Okay? Oh, fine. And it does 100 joules of work. So work done by the system is 100 joules and work done by the system is also positive. Okay? Now from here, can we find out the change in internal energy when the system moves from A to B? Yes, we can. Kaise? We just need to use the formula of delta Q is equal to delta U plus work done. Okay? Delta Q 400. Delta U from A to B is equal to final minus initial. Delta U matlab change in internal energy, right? System moves from A to B. So change will be equal to final internal energy minus initial internal energy. UB minus UA. ठीक है? Plus work done is 100. Okay. So UB minus UA is equal to 400 minus 100 हो जाएगा 300. Okay. Though this is not our question, this is not what we are supposed to find out. Anyway, हम तो find out कर दिया. ठीक है? Extra information. Let's continue doing reading the question. If the system moves from B to A, what is the change in internal energy? Entire information was given for the system moving from A to B. Question is, if the system is moving from B to A, change in internal energy क्या होता है? How do you write the change in internal energy? Final internal energy, that is UA minus UB, isn't it? Can I write the same thing as minus of UB minus UA? Possible, right? Because if you take the negative inside, you'll get the same thing. Okay, this is negative of UB minus UA का value क्या है? 300. देख ले from here. So UA minus UB is equal to minus 300, or the change in internal energy when the system moves from B to A का value है minus 300. ठीक है, समझ में आ गया सबको? नोट डाउन कर ले जल्दी से. Everyone note down the answer as soon as possible. The concept should be clear. That's all. If it's clear, then good. Okay, very good. Who all have given the answer B? I'll see Nandini, Sumit, Ayan, Rinshki, Sumit. Very good मेरे बच्चा लोग. Awesome, very good. ठीक है, note down किया? Last 5 seconds more. 5, 4, 3, 2, 1. Okay. Next question. Fine. बड़ा question है. So just go through it. आराम से try to understand. Even if I start doing the answer, okay, you can continue doing the problems and solving it by yourself. Okay. So start reading everyone. जल्दी से and start doing the problem by yourself. आ गया समझ है ना बच्चा लोग? Noted. ठीक है. मजा आ रहा है टेक पीआर? बढ़िया बात है, मजा आ रहा है तो समझ में आ गया तो सब मजा भी आ जाएगा ना. मजा ऐसे आ जाएगा साथ. How many of you completed reading the question and started doing the problem? How many of you? Okay. So, shall I start doing it? I know that it's a big question. It will take some time for every one of you to give the answer. ठीक है? So, कोई बात नहीं. Listen to me here. In the meanwhile, you can continue doing it and keep on giving me the answers here in the chat box. Fine? Okay. Let's see who's going to be first. Ameer भैया और आप लोग. देख ले. 1 gram of water vaporizes at atmospheric pressure. मतलब pressure is a constant. I'll write here. Pressure is a constant. Fine. Then its volume in the liquid state is this much and its volume in the vapor state is this much. मतलब liquid is converting into volume. Liquid is converting itself into vapor by having a change in volume. Fine. Find the work done in the expansion, first thing, and the change in internal energy of the system. 2 questions are there. First thing, what is the formula for work done, right, of a thermodynamic process when pressure is remaining as a constant? We all know that is equal to P into V2 minus V1 or P delta, right? Okay, pressure का value क्या है? 1.01 into 10 power 5. Okay, what is final volume? 1671 minus. What is the initial volume? 1. It's in centimeter cube. How will you convert into meter cube? Multiplying it with 10 power minus 6. Okay. Now, how much will this be? 1.01. 10 power 5, 10 power minus 6, 10 power minus 1. This is 1670. Right? So 10 power minus 1, the 0 will get cancelled. 167 into 1.01 will become 169 joules. So directly we got the value for work done. Simple as that, isn't it? Yes or no? और क्या सर, बिल्कुल सही है, आपको मिल गया. Okay, आपको मिल गया. Who is first? Did anyone give me the answer? Okay, everyone already gave me the answer for the second part, right? Everyone is like, sir, B, 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 B. ठीक है, ठीक है, ठीक है. We'll also find out the answer for the second part. First part is this. Second part क्या है? The change in internal energy. कैसे? Change in internal energy का value, how can we find out? We simply have to use first law of thermodynamics. Delta Q is delta U plus work done, isn't it? Yes. Now, work done का value already we have. Delta U has to be found out. Delta Q का value, how can we find? What is delta Q? Heat energy given, right? And whatever heat energy is given is used for change of state from liquid to vapor. So tell me, what is the formula to find out heat energy, right, during a change of state? How many of you do remember that? Let me see. Heat energy given is equal to, during change of state, mass into latent heat of vaporization, isn't it? Yes, because here we are converting a liquid into its vapor state. So the heat energy is given for changing the state of the body, and the formula is this. Start substituting. Mass is how much? 1 gram, that is equal to 10 power minus 3. Latent heat of vaporization is 2.26 into 10 power 6. So this become 2.26 into 10 power 3. So this will be 2260 is equal to delta U plus work done कितना है मेरा बच्चा लोग? 169. ठीक है, सब्स्टिट्यूट कर ले. डेल्टा U is 2260, 169, almost it will be 209. Okay, so the change in internal energy value we got, it's option D. And let me see how many of you got that answer. किस बच्चा लोग को मिल गया the fourth one as a correct answer? किसी को भी नहीं? So Bhaiya is the first person to get the correct answer. Is it so? Is it so? Is it so? Is it so? Is that the case? No, Ayan already got. You understood, right? Rinsuki. Very good, very good. Awesome, awesome, awesome. So copy भी कर दिया सबने? Everybody copy down. Copy भी कर दिया है ना? No doubts, no doubts. ठीक है, ठीक है, ठीक है. So हम जा रहे हैं अगला क्वेश्चन के लिए. रेडी है ना? नहीं मिला सर, बट आप समझ में आ गया. अरे वाह, इससे ज्यादा क्या चाहिए मुझे? क्रिस्टल क्लियर. ठीक है. सो अगला क्वेश्चन पे हम जा रहे हैं. ये कर ले. आई होप यू डू रिमेंबर, right, molar heat capacity. Now don't type this question in what's a Google or wherever you type to check the answer whether it is correct or not. ठीक है. So Google में it's a different form it is given. So if you go there, you will get the wrong answer. Okay, so many of you were there in my classes, I suppose. Many of you are giving the options D. Kapil. Hi, NK. Hi. Rukshar. Very good, very good, very good. So many of you do remember this question, right? Many of the questions, whatever we are doing, as it's a revision class, we have done in our usual classes itself, right? It's good actually. Anyway, let's do it. For hydrogen, Cp minus Cv is equal to A. And for oxygen, Cp minus Cv is equal to B. Okay. Now where C is molar heat capacity. Most of the questions in Google is related to, right, specific heat capacity. The Cp and Cv corresponds to specific heat capacity. There the answer will be different. Okay, the answer will be coming as with 16. But that's not our question here. Here we have molar heat capacity. In molar heat capacity, Cp minus Cv ka value will always be a constant, which is our universal gas constant, with a value of 8.314 joule per kilogram Kelvin. This will be 8.314 always. Okay, if Cp and Cv corresponds to molar heat capacity at constant pressure and constant volume respectively. Okay, if it is specific heat capacity, there will be a difference in answer there. Okay, but here it's this is the value going to be. Okay. Yes, it's option D. Very good. I'm so happy. Many of you do remember. Arey wah. You know why I feel so happy? Because even in offline classes, right, we can approach the students and ask them, okay, why you haven't studied or something. Even if it's an online class, even if it is YouTube, you guys are learning all the questions what we did in our classes. That means awesome. You guys are super awesome. Beautiful. Next. Next question is waiting for you, मेरा बच्चा लो. Okay, नन्नू मुन्नू question है. Let me see who all are giving me the answers right now. कौन कौन दे देगा? कौन कौन बच्चा लोग दे देगा मुझे सही उत्तर? Hi Jashin, hi. CV, molar heat capacity at constant volume. Karthikeya, the bottle is from Decathlon. सीख है आपका. Your eyes are on my bottle, not on the board and whatever I am writing, है ना? Okay, you can continue doing the problem. I'll start explaining here. But anyone do have an answer or what? I'll be so happy if someone gives me the answer. Okay, you guys are still doing. Anyway, ठीक है, let's do it. For an isothermal thermodynamic process, isothermal matlab temperature constant. Those who don't know, write temperature. If temperature is remaining as a constant during a thermodynamic process, we call it isothermal process. Okay. Initial pressure and initial volume ka value is given. Now the pressure of the container is doubled. Find the volume. If it's an isothermal process, we know P1 V1 is equal to P2 V2, right? Because PV value is a constant. Now just start substituting and find out the volume afterwards. That's it. What is initial pressure? How much is it? 10 power 6, right? Yes. Initial volume, it's 3 meter cube. Final volume, array the pressure is being doubled, right? Sorry, final pressure. Pressure is being doubled. Initially it was 10 power 6. So the final pressure is 2 times 10 power 6. Because when the question says pressure is doubled, okay, multiplied by V2. 10 power 6 will get cancelled. V2 will be equal to 3 by 2. Okay, how much is this? 1.5 meter cube. And that's our answer. Simple as that. Not a big deal. Any doubts? Nobody can have a doubt on this. Isn't it? Nobody can have a single doubt on this. Because क्या हो सकता है? Because isothermal process, we know this equation is being satisfied. Substitute कर ले. Find the unknown. That's it. You all can note it down as fast as possible. जल्दी से, फटाफट से. Sumit C, Karthikeya C. Yes, it's option C. Good. Next. Ready? Okay. Agla question. Look into the question. Think what is being asked. Start analyzing how to start the question, how to get the final answer. Think about that formula which will lead you to the final answer and get the answer. That's it. That is the general way of solving any problem. So, jaldi fatafat, go for it everyone. Whenever you come to my classes, Ameer Bhaiya ka classes, which means my classes, you should be totally alert and active all the time. Okay, you should be like when I'm gonna get the question. Whenever you get the question, at that moment your brain should start working, your hand should start working. You should be able to solve the problem within seconds, or I'll make you to be in that particular stage soon. So what do we have here? What do we have? Meru, Sumit, then Tech PR. Okay, Mihir Kant, Sumit. Okay, good, 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 good. Awesome. Many are giving which options I say? Many are giving the option C here, which is 13380. Let's see. Let's see. Okay. Work done by the gas is a question. If 5 moles of an ideal gas is being carried by a quasi-static isothermal process, underline what kind of process we are talking? Isothermal process at 500 Kelvin to twice its volume. Volume is getting doubled. Matlab final volume V2 is 2 times the initial volume. In that case, what is the value for work done? What is the formula for work done in an isothermal process? How many of you do remember? Dekhli, it's N R T ln V2 by V1. Okay, now start substituting. N, number of moles, 5. R ka value constant, we already know. Temperature, what's the temperature? 500 Kelvin. Temperature, make sure that the unit of the temperature is always Kelvin. Here, it's not a big deal because it is directly given in Kelvin itself. Sometimes it will be given in degrees Celsius or any other scale. But whenever you apply it in any equations of thermodynamics, okay, make sure that the temperature is in what? Kelvin scale. Okay. ln V2 by V1. V2 का value क्या है? 2 times V1 by V1. V1 by V1 will get cancelled. So this will be 5 into 8.314 into 500 into ln2. Okay. So among the logarithms, it will be great if you can by heart the value of logarithm of 2 to the base e. 0.693. Those who don't know, logarithm to the base e 2 ka value has 0.693. Kindly by heart this. Those who don't know, those who haven't by hearted till now, ये by heart kar le. Very important. Because in many of the questions, right, for 11th standard and 12th standard, you will find this logarithm to the for 2. So if you try doing this, how much will you get? You will get the answer as 14407 joules, which is option B. ऐसे मिल जाएगा, ऐसे फटाफट मिल जाएगा, आसानी से मिल जाएगा ऐसे. Got it? Is it clear? Sumit, Kapil, Karthikeya. Okay. Yes. B. Fine. Awesome. Very good. Very good. Arey Maru, thank you so much for supporting me. But we don't have to look into the chats of useless people, right? Right? Let them do whatever they want. They are doing all these things for getting famous or taking their names in the classes, right? That's what they do. Because we can say their life will be a waste in that way. We don't have to consider those people. What we are doing is a very amazing thing here. We are learning physics. We are preparing for the term 2 and all the competitive examination. Let's focus on that. Why we have to waste our focus on concentration on some unwanted peoples here in this class, right? So yes. Clear, right? Aditya. Awesome. Sumit, yes. Kinetic theory, the topic is already being completed in our classes, मेरा बच्चा, ठीक है? Fine, we'll be doing the numerical questions soon. In the next class, we'll be doing the questions from kinetic theory only. ठीक है? Fine. So I hope you all have noted down all the steps, understood all the steps, and understood how the final answer is option B. Okay? Next question के लिए जाएगा? Okay, here we go. This is a very good conceptual question related to work. Let me see how many of you can crack this particular problem. Those who can, right? I'll say hats off. That'd be a great thing. Everyone, just go for it. That's what I'll say. Hi, hello. Hi, Niti. सब बढ़िया है ना सबका? बच्चा लोग सब बढ़िया? Everything is going good, I suppose, right? Okay. So let's make it more and more good, है ना? Because we are doing problems here. So हो जाएगा. So anyone do have the answers? Hi, Niti. Okay. Hi, Nishant. Hello, Aryan. Aryan is going for the option B here, which is nRT by 2 with negative sign. Okay. Minus nRT by 2. Anyone else? Sumit is going for the option B. Check the option. This is not logarithm. Minus nRT by 2 it is. Here plus nRT by 2. This is nRT ln2. This is minus nRT ln2. Okay. So everyone is still going for the option B here. Let's see. देख ले. N moles of a gas are filled in a container. As you can see here. This is a container. N moles are being filled in this container at some temperature T. If the gas is slowly and isothermally, देख ले, it's an isothermal compression to half its initial volume. Initial volume, let's say it's V, okay, V1. So the final volume V2 is equal to V1 by 2. Because we are compressing, we are moving this piston towards left and we are compressing this particular gas here. Fine, okay. Now the work done by the atmosphere on the gas. Work done by the atmosphere. We'll come to it later. First, we will do whatever we have learned till now. That is work done by the gas. Shall we do that? ठीक है. Formula क्या है? Work done by the gas in an isothermal compression. Formula nRT ln V2 divided by V1. Isn't it? This is nRT ln V2 कितना है? V1 by 2 with V1, right? So this I'm going to write it as nRT ln V1 cancel. 1 by 2 I'm going to write it as 2 raised to minus 1. Those who don't know, there is a nanu-munu property related to log which will be coming to your use all the time. So ये by heart कर ले. That ln a raised to n will be equal to n times ln a. This is very important. बहुत important है. Similarly, ln 2 raised to minus 1 will be equal to minus 1 into ln a. Here it is 2. ये क्या है? Is this our final answer? बिल्कुल भी नहीं. This is work done by the gas. It is minus nRT ln 2. Okay. Now let us get into the picture and understand more about it. देख ले, here we have gases, gas molecules. Gas molecules, because of its pressure, will be giving a force in this direction, right? Because molecules will be continuously striking on this particular piston, a force is given here, right? And with this force given by the gas, we are moving the piston towards right by making a displacement of S, let's say. Even though the force is towards right, however, the piston is moving towards left because outside someone else is providing a force. Who is providing the force? So it is the atmospheric force which is present here, which is making the piston to move inwards and compress it. So question is to find out what? To find out the work done by the atmosphere. What is the formula for work done by atmosphere? Bol de. Okay, look into the figure and tell me what will be the formula for work done by the atmosphere. Work done by atmosphere is equal to atmospheric force Fa dot displacement, let's call it as S. We know that it is a quasi-static process. मतलब the entire system will be in equilibrium during the compression. इसका मतलब ये कि right, atmospheric force Fa and gas force will be equal and opposite. Why they have to be equal? Because this is in equilibrium. This is a quasi-static process, right? A quasi-static thermodynamic process is that kind of process where it will be in equilibrium with the surrounding all the time. So if the system wants to be in equilibrium with surrounding, the forces has to be equal. So force provided by gas and atmosphere should be equal. As they are in the opposite direction, we have a negative sign. Okay. So Fa can be written as what? Fg with negative sign dot S. Yes or no? Yes. So force given by gas into displacement क्या है? Force into displacement, force given by gas into displacement, yes, that is work done by the gas. ये होता है ना? Fg into S, that will be work done by the gas. So work done by atmosphere is negative of work done by gas. So work done by atmosphere is equal to negative of work done by gas. कितना है? Minus nRT Ln2. Work done by gas already have a negative sign. ये दोनों negative sign cancel हो जाएगा. Final answer is nRT Ln2. nRT Ln2. But yeah, so third one will be our correct answer. No doubt in that. Simple. Nannu Munnu concept. It's plus nRT Ln2, which is option C. This one. Option C. I have marked it. Yes. Okay. So don't go for the option D there. It's with a negative sign. I hope सबको concept मिल गया. Right? I hope you all understood the concept. Best of luck, Himanshu. Okay. I know that you might have prepared in the best way possible. So getting a very good mark for your chemistry exam or any exam, let it be. For my bacha log, it's not a big deal, isn't it? Anyway, all the best, Himanshu. नन्नू मुन्नू क्वेश्चन था, है ना? सुमित ओके, सर क्लियर कार्तिकेय? बढ़िया बढ़िया बढ़िया. कोई भी डाउट्स है क्या बच्चों लोग? From all the questions that we have done till now, just want to copy it down. जल्दी से copy down कर ले. I'll stay on the other side. Bottle is from Decathlon. और क्या? कहाँ से खरीदूं मैं? ठीक है? So yes, moving on. अगला क्वेश्चन तो आ गया है. सो आ गया तो कर ले. अरे इसमें करने को क्या है? इतना इतना नन्नू मुन्नू क्वेश्चन है ये. इतना अच्छा नन्नू मुन्नू क्वेश्चन है ये. सो ज्यादा करने का भी नहीं है ना? No doubt, all clear. Fine. So second beat again. Second beat. किसका beat? Ayan is going for the option B here, right? A here. Fine. Okay, great. Now, first law of thermodynamics is an isothermal process. Isothermal process का मतलब ये है कि change in temperature zero है. We know that internal energy is directly proportional to temperature, right? So if change in temperature is zero for an isothermal process, change in internal energy will also be zero because internal energy directly proportional to temperature, right? So if temperature is not changing, if temperature is a constant, internal energy will also be a constant. If internal energy is a constant, change in internal energy, change in constant value will be a zero. Okay, so in that case, what will be the first law of thermodynamics? Write it. Basic formula, delta Q is delta U plus work done. We all know this formula, right? For isothermal, delta U ka value 0 hai. So this equation can be simplified as delta Q is equal to W, and we will get the fourth option as our correct answer. Okay, option D will be our correct answer. Option D will be our correct answer. I hope this part is clear because this concept, this is a very important concept because you'll find this concept used in many part of the numericals from this particular chapter. बहुत सारे parts पे. So be careful and yes, keep this in mind. हो गया ना बच्चा लोग? हो गया तो हो गया, बच्चा लोग हो गया. ना 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 ना. अगला question. Ready? Everyone? सही है? Are you all ready for that? C for chunnu munnu concept. Okay, so the correct option is D, as I have already marked, है ना? Note भी किया? ठीक है. अगला question. वाह 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 वाह. Now try doing this problem and make sure that your complete concentration will be with your bhaiya when I explain the concept of this PV graph. क्योंकि है ना, this is very important and there is 100% chance that if a question is asked from thermodynamics, mostly it will be from graph, or at least the concepts of graph will be used in that particular question because it's that important. So Abhi, you guys try right now, you all try it. Okay, if you are not able to, I'll be explaining it. So go for it, everyone. Okay, waiting for every one of you to give me the answers. Jaldi. Noted. Meru, yes. Sumit, yes. Ansh, B. Okay, everyone is going for the option B here. Let's see कैसे करेगा ये. Okay. A thermodynamic system is taken through the cycle ABCDA. मतलब it starts from A, move to B, then to C, to D and A. मतलब initial position and final position तो same है. In that case, change in temperature कितना हो जाएगा? 0. मतलब the total change in temperature will be equal to 0. If change in temperature 0 है, delta U be 0. This is a concept which we already have discussed, right? Okay. Question. Heat rejected by the gas during the cycle is. मतलब we are asked to find out heat rejected और delta Q का value. कैसे करेगा? Just use हमारा first law of thermodynamics formula. Delta Q is delta U plus work done. Delta U तो 0 है. क्यों? Isothermal process. So delta Q, which is asked to be found out, will be equal to what? Work done. So instead of finding delta Q, we can just find out work done. Okay? Because work done is equal to delta Q. Look, tell me, if we have a pressure volume graph, just like in this question, how can we find out the work done? Who can tell me? Work done is area under PV graph. Okay? Area under PV graph is actually the work done. So I'm going to split this particular thermodynamic process into 4 different graphs. देख ले from A to B. Okay. A to B, B to C, C to D and D to A. One thing I can directly tell you. Work done from B to C. Work done from B to C. Okay. From B to C and work done from D to A. Value कितना हो जाएगा? How much will be the value for work done in that case? When it moves from B to C, देख ले, volume is a constant, isn't it? So if volume is a constant, work done is 0. D to A. Volume is a constant throughout the process. So in that case also, work done is 0. So for finding total work done, right, we just need to find out the work done during A to B and C to D, because remaining 2 cases work done 0 A. Okay. From A to B, work done during A to B. It is area under the work done. Okay. How much is the area under the work? Area under the graph from A to B? ये है ना? That is equal to pressure corresponding to the graph, that is P, into change in volume. Final volume is 3V and initial volume is V. So work done will be equal to, देख ले, final volume is 3V, initial volume is V, 3V minus V is 2V, 2V into P is 2PV. Positive or negative? Positive. So work done during the process of A to B plus 2PV. Similarly, work done from C to D. From C to D, what is it actually? It is the area under the work done. कितना होता है the area under the work done? इतना. This is the area under the work done, right? What will be the area? Array, dekh le, this much area is a rectangular area. That is equal to length into breadth. So this much is, this length is how much? 2p. Okay, and this breadth will be equal to how much? 3v to v, that is change in volume, v minus 2v. So this will be minus 4 pv. Okay, so we know the work done from A to B, B to C, C to D, D to A. Add kar le to find out the total work done. So total work done is equal to work done from A to B, B to C, C to D, D to A. Add kar le. Total work done will be equal to adding up all the values. Two values are already 0, as we already know. Dekh le. Two values are already 0, as we can see that. Now adding up the remaining work done, that is plus 2 PV minus 4 PV. Plus 2 PV plus 0 plus 0 minus 4 PV. So this is equal to minus 2. So work done is minus 2 PV. Question was what? What is delta Q? Delta Q ka value equal to work done for an isothermal process. Work done is how much? Minus 2 PV. So delta Q का value is minus 2 PV. What does minus sign suggest? मेरा बच्चा लोग सुन ले. Minus sign का मतलब ये है कि सर क्या था? क्या था? हाँ, minus sign का मतलब ये है कि heat energy is being released or rejected. And how much it rejects? 2 PV value. So by a magnitude of 2 PV, heat energy is being released. So heat rejected is how much? 2 PV. So you don't ask me, sir, minus kahan gaya? Array, minus is just to represent that heat is rejected. So as the question is already heat rejected, just tell the value 2 PV is being rejected. You don't have to put a negative sign to show that again the heat is rejected, because the question itself is heat rejected kitna hai. क्लियर है नन्नू मुन्नू? मेरे नन्नू मुन्नू प्यारा बच्चा लोग, क्लियर है? हैव अ लुक हियर एवरीवन, अच्छे से हैव अ लुक एट ऑल द स्टेप्स. ट्राई टू एनालाइज, ट्राई थिंकिंग, हाँ ये स्टेप कैसे आ गया, ये स्टेप कैसे आ गया, एंड हाउ वी एंड अप इन द फाइनल आंसर. मिल गया ना सबको? मिल गया ना सबको? Very difficult problem. Arey baap re. At least after my explanation, now it's simple for you, right? I'm right, Sumit. Very good. You have to be. And yes, it's B. Good. Note B kiya na? Okay. Agla. A direct question, let's say. Seedha saada question. Nannu munnu question. सीधा साधा क्वेश्चन के लिए उत्तर दे दे मेरा प्यारा बच्चा लोग, जल्दी से. Who's going to give me the answer? 5 more seconds only you will have. Last 5 seconds. Ayan is going for D. Anyone else? Meru is going for D. Check your answer. Okay. So I think many of you will be going for the option D by mistake. I'll explain you. Dekh le, everybody listen. The internal energy of a gas in an isothermal process. Isothermal process का मतलब क्या है? Temperature is a constant. है या नहीं? हाँ. Temperature constant है तो internal energy U, which is directly proportional to temperature, वो भी constant हो जाएगा. So internal energy will also be a constant. And as internal energy is a constant, change in internal energy 0 होता है. So what did I say? Change in internal energy is 0, and for an isothermal process, internal energy constant हो जाएगा. Change is 0, value is a constant. What is asked? The internal energy of a gas, not change in internal energy. If the question was change in internal energy, answer would have been 0. But here, what is the internal energy? It is a constant. What is the internal energy? It is a constant, or it remains as a constant. So here we have the option C as our answer. Okay, cool. So now understood why the answer is option C. Ansh, option A, बिल्कुल भी नहीं, decreases. कैसे? Lina, yes, option C. Very good. Okay, बढ़िया बढ़िया बढ़िया. आ गया ना समझ? Every one of you? कैसे आ गया option C? Okay, there shouldn't be that doubt at any point in your mind. आ गया तो आ गया. Okay, next. I want every one of you to give your complete attention. It's a very good question, right? Try to solve it by yourself, not from here and there. ठीक है, बिना कॉपी करके whatever you got it from the question, try solving it. जल्दी. You all have, let me say, 15 more seconds for solving this. कौन कौन करेगा ये? कौन बनेगा करोड़पति, है ना? Anyone? Anyone? Last 5 more seconds. If you want to answer, jaldi se answer kar le. Else I'll start explaining. But don't stop answering in the chat box. Even if I'm explaining, keep on answering. ठीक है? Keep on doing it. Don't stop. Don't stop. Don't stop picking more. Yes? Lena. Okay, let's get started. And here we go. A cylinder contains 5 meter cube of an ideal gas at a pressure of 1 bar. Okay. The gas is compressed in a reverse isothermal process until pressure is increased to 5 bar. Okay. Initial volume, initial pressure, final pressure is given. The work done in kilojoules required for this processes. Ln5 का value भी दे दिया 1.609. कैसे करेगा? How can we do this? Very simple. Shall I tell you? We just need to use the direct formula for work done in an isothermal process. What is the direct formula? That is equal to nRT ln V2 by V1, right? As pressure, initial value and final value is given, we know V2 by V1 is equal to P1 by P2. This is another formula, right? So it is nRT ln P1 by P2. Now देखिए nRT का value नहीं दे दिया है because temperature is not given, number of moles is not given, but we know nRT will be equal to what? PV. ये कहाँ से मिल गया सर? Okay, this is a new formula. अरे, those who are in chemistry classes, everyone will be doing an ideal gas equations. We have learned in the kinetic theory of gases in physics itself. So nRT, I'm going to substitute it as PV. PV is equal to ln P1 divided by P2. Okay. Now PV is a constant, so you can take a P and V value at any point. देख ले directly initial volume and initial pressure is given, so substitute कर ले. Pressure कितना है? 1 bar, that is equal to 1.01 into 10 power 5 Pascal, because Pascal is the SI unit and 1 bar का value 1.01 into 10 power 5 Pascal. ठीक है. Volume how much? 5. ln P1 by P2. What is the initial pressure मेरा बच्चा लोग? 1 bar, right? What is the final pressure मेरा बच्चा लोग? 5. 1 by 5. So this will be 1.01 into 10 power 5 into 5. ln 1 by 5 is ln 5 raised to minus 1. Okay, ln 5 raised to minus 1. ठीक है, so this is equal to ln a raised to x का value है ln a raised to n का वैल्यू है n times ln a. This thing I already have told you. So ln 5 raised to minus 1 is minus 1.01 into 10 power 5 into 5 into ln 5, 1.609. So 5 into 1.609 into 1.01 will almost be approximately 8.04, let's say, into 10 power 2 into 10 power 3. 10 power 5 split करके 10 square into 10 power 3. Okay, इतना joules. So 8.04 into 10 square will be equal to 804. 804 into 10 power 3 joules or 8.4 kilojoules, right? Because the question is to find the work done in kilojoules. And I hope you all know what this negative sign suggests, right? Negative sign suggests that work done negative matlab work is done on the gas. Work done by the gas to positive hai. Work done on the gas is, yes, negative. If work is done on the gas, what will happen to volume? Volume to decrease ho jayega, right? So if volume decreases, work done will be negative. Or we can say if work done is negative, volume will be decreasing. That is also something which we can see. Okay, ठीक है, आ गया समझ? The first option is the correct one. सबको? This formula stick in my mind like glue. That's a good thing. Everybody will be knowing ना PV equal to nRT. सबको पता है. I think you all wish like all the formulas of physics and chemistry and all the subjects to be stuck in your mind just like this particular equation PV equal to nRT, right? I know that many of you are thinking like this. So ऐसे हो गया तो कितना अच्छा हो जाएगा, है ना? PV, like PV equal to nRT, if I know all the problems, okay, most of my problem of life will be solved. Because many of the numericals can be solved if I do remember all the formulas. I know that that's what you're thinking. Anyway, बढ़िया बात है. So ये किया है. अगला क्वेश्चन पे जा सकता है ना? देख ले क्या क्या किया है. What all formulas, what all steps we have used. So देख ले, अच्छे से देख ले. Any doubts you have, कुछ भी है तो बता दे. Nothing is there, I can move on. I'm gonna just look into the chat box. Okay, I can see crystal clear and all those stuffs. So ठीक है. आ गया तो आ गया, समझ में आ गया. ठीक है, हम तो अगला क्वेश्चन पे जा गया. करके दिखा, करके दिखा, यही वाला क्वेश्चन करके दिखा. हटा दिया, so that you will not be having any troubles here. Everyone, जल्दी से. Answers? So I'll start, right? I'll start explaining मेरा बच्चा लोग. ठीक है, I think you have done your part. You have tried doing this particular problem and I can see who gave me the answer. Mero gave me the answer, option C. Let's see हमारा option C. Let's see हमारा option C सही है या गलत. Whether it is correct or not. देख ले. A piston cylinder device initially contains 0.4 meter cube of air at 100 kilopascal and 80 degrees Celsius. Fine. The air is now isothermally compressed. Sir, बहुत सारा isothermal आ रहा है, बढ़िया तो है, right? The concept of isothermal will be there in your mind. You will not be ever forgetting it. ठीक है. It is compressed to a volume of 0.1. Okay. The work done during the process is sign convention. Work done on the system is negative. Oh, question is like we'll tell you, we'll give you some information. हमको पता है ना? Work done on the system is negative itself. ठीक है, इट्स नॉट अ बिग डील, हमको पता है. ओके ठीक है. कैसे? यूज द फॉर्मूला. वर्क डन का फॉर्मूला इज nRT ln V2 divided by V1, right? Are all these values given? nRT values नहीं दे दिया है, लेकिन nRT हमको पता है, that is equal to PV. पता है ना? So nRT I'm going to substitute it as PV here. मेरे बच्चा लोग देख ले, PV ln V2 by V1. PV is a constant, so you can take any values of pressure and volume. So देख ले, I'm taking initial value of pressure and initial value of volume. Okay, but don't take any value of pressure and volume. मतलब from the initial part I'm taking volume and from the final part I'm taking pressure. ऐसे नहीं, right? We should be taking pressure and volume at a particular instant. Okay, at this instant or at the afterwards instant, initial instant या final instant. Anything is possible, but don't mix up and take. समझ में आ गया? I suppose what I wanted to convey you. Okay, ठीक है. Pressure and volume I'm taking initial pressure 100 kilopascal, 100 into 10 power 3. Volume कितना initial? 0.4 ln V2 by V1. V2 कितना है? Final volume is 0.1. इधर है. Initial volume कहाँ है? इधर है. ठीक है. 0.4. So how much this is going to be? What should be the answer? Should be in kilojoules, right? So this will be 40 into 10 power 3 into ln. This becomes 1 by 4. 1 by 4 matlab 1 by 2 square. That 2 square I'm going to write it as 2 raised to minus 2. We have learned this particular concept so many times. बहुत सारे time किया है. ln a raised to n is equal to n times. So minus 2 times 40 into 10 power 3 into ln 2. अब क्या बाकी है? कुछ भी नहीं. ln2 का वैल्यू सब्स्टिट्यूट कर ले. That is equal to 0.693. So 0.693 into 40 into 2. 40 into 2 is 80. 80 into 0.693 we'll get almost a value of 55.45. Okay, with the negative sign into 10 power 3 joules, or नहीं तो minus of 55.45 kilojoules. 10 power 3 joule is equal to 1 kilojoule. So we can have answer. किस आंसर मिल जाएगा बच्चों? अरे यार ये जाओ भाई आप जाओ. अरे ये नहीं मूव कर. ठीक है ठीक है आ गया. So हमको मिल जाएगा ऑप्शन सी एज अ करेक्ट आंसर, राइट? Not a big deal. Everything I have used accordingly. Okay, as you can see, that series of steps we have used to get into the final answer. Not a big deal at all, isn't it? Yes or no? Yes. See, it is. Badhiya. Any doubts? जल्दी से पूछ ले. Clear all your doubts. Fine. जल्दी से पूछ ले. Clear all your doubts. I suppose कुछ भी नहीं है. कुछ भी नहीं है ना? So proceed. Okay. Yes. Next one. Not a tough question. सीधा साधा नन्नू मुन्नू question है. So I'm expecting every one of you to do it. Read the question अच्छे से. ठीक है. Grab everything what is possible. Information बना दे. Equation बना दे. ठीक है. Get your final answer. I'm so eager to know who's gonna get the correct answer. Who is gonna get? Who is gonna get? All clear? No doubts? Abhiram? Okay. Nannu Munnu? Yes. Nannu Munnu. Nannu Munnu. Anyone? Do anyone have the answer? Okay, कोई बात नहीं. What you can do is you can keep on posting the answers here in the chat box itself. ठीक है? In the meanwhile, I'll solve. A monoatomic gas is suddenly compressed to 1 by 8 of its initial volume adiabatically. क्या है? Adiabatically. Adiabatic का मतलब ये है कि there is no exchange of heat energy between the system and surrounding. Delta Q का value 0 है. That's what you mean by adiabatic. Okay. So it says final volume is equal to 1 by 8 times the initial volume. This is the first part of the question says. Okay. The ratio of final pressure to initial pressure. P2 by P1 का value has to be found out. Specific heat ratio is given, right? Okay. 5 by 3. Gamma का value. ठीक है? Now, by using all these information, how can we find P2 by P1? Array. Everybody knows. We know P1 V1 raised to gamma is equal to P2 V2 raised to gamma. पता है या नहीं? पता है. Right? That is how you represent an adiabatic thermodynamic process. Start substituting. P1 into V1 raised to gamma is 5 by 3 is equal to P2 into V2 is equal to 1 by 8 V1. 1 by 8 V1 whole raised to gamma is 5 by 3. V1 raised to 5 by 3. V1 raised to 5 by 3 cancel हो जाएगा. This 8 raised to 5 by 3 comes to the left as 8 raised to 5 by 3 ऐसे. P2 here we have. P1 goes to the right hand side as denominator. So P2 by P1. 8 raised to 5 by 3 का value क्या है? 8 raised to 1 by 3. मतलब cube root of 8. How much? 2. Because 2 2s are 4 2s are 8. So cube root of 8 is 2. Then we have 2 raised to 5. 2 raised to 5 कितना? 2 2s are 4 2s are 8 2 16 2 32. Right? So this is equal to 32. So P2 by P1, which is asked here, is having a value of 32. Is having a value of 32. So you should be knowing adiabatic thermodynamic process we are talking. We should be knowing the equation to represent that. Just correctly substitute all the values. आंसर ऐसे आ जाएगा. कितना स्मूथली है ना, इतना स्मूथ से. ओके, यू वोंट इवन अंडरस्टैंड हाउ वी गॉट द आंसर. उतना स्मूथ से आ जाएगा हमको उत्तर. मिल गया ना? ओके. यस. क्या हम नीट की प्रिपरेशन के लिए इकट्ठे आए, बट यहाँ लग नहीं रहा है हम नीट क्वालिफाई कर पाएंगे. डिप्रेस हो रही कोई. अरे just hold yourself tight, है ना? So just keep on putting yourself, okay? Just keep on fighting for your life always, because never stop at anything in your life, okay? Wherever you are. So what you need to do? Just keep on fighting, keep on fighting, keep on fighting. मिल जाएगा आपको, okay? If you don't get, who is going to get? Sometimes it takes time for you, right? For anyone. So for some people they'll get easily. For some people it will be hard. But those hard roads you take will only make you so much harder in your life, so much tougher in your life, so much stronger in your life. Just keep that in mind. Okay, fine, awesome. Teaching is the best. Thank you so much. So is this concept clear sabko? अच्छे से, प्यारा से, right? Shall we proceed? Okay, here we go. Next question. And this is a very good question. And it's a lovely question, and it's a simple question at the same time. So I'm expecting correct answers from you. Jaldi se. Karke dikha, karke dikha. Last 15 seconds you have. After that I'll start solving. Anyone already gave me the answer or what? किसी ने दे दिया क्या? Already answer. Very good, Abraham. Best of luck. Just go and rock your exams and come with full marks, okay? Okay, so I think you are taking time, so कोई बात नहीं, keep on giving me the answers. In the meanwhile, I'll also solve the question here. Okay, देख ले. During an adiabatic expansion, adiabatic expansion क्या था? A thermodynamic process where there is no exchange of heat energy. मतलब delta Q, change in heat energy zero हो जाएगा. Okay, that is what you call adiabatic. 2 moles of gas, the change in internal energy was found to be minus 50. Delta U का value minus 50 है. Okay, work done का value कितना है? Delta Q, delta U and W. Which equation does it remind you of? First law, which says delta Q का value मेरे बच्चा लोग delta U plus work done. Substitute कर ले, whatever is given, delta Q का value 0, delta U का value minus 50, work done हमको पता नहीं. Now minus 50, take it to the left hand side, plus 50 is equal to work done. So work done का value है 50 sir. 50 sir, मिल गया. Very simple. You should be knowing delta Q equal to 0 for an adiabatic. If you know that, हो जाएगा. And I think many of you have by hearted. For an adiabatic, work done is equal to delta U. Isn't it? Many of you have by hearted. Those who know that, directly we can answer it. Work done is equal to minus delta U. Yes, homicide gamer, very good. Sumit is giving me the option A. Ansh बोल रहा था कि A, Meru A, Abhiram 50. Okay. Sumit A, very good, very good, very good. You guys are the best. Okay, so it's option A, not asking whether you understood or not. Nannu Munnu question. Okay. Next one. Go for it. Everyone. Sir, कितना देर की class है? We'll extend up to 4 o'clock or 4:10. Okay, we have 10 more questions. So whenever we complete that 10 more questions, ठीक है, I'll leave you all. Butter question ये, ठीक है कर ले. Don't make mistakes, okay? Mistake मत बना दे. Because there is a slight chance that you will go for the wrong answer here because of being careless. But I know that many of you will be careful here. Priyansh बोल रहा है कि A, Ansh S बोल रहा है, there is no option S here. Ansh A, Sumit A. So yes, many of you are going with the option A here, right? ठीक है, let's find out. Tire is at 27 degrees Celsius. We know whenever we use it in the formula, temperature has to be in Kelvin. So initial temperature is 27 plus 273, that is equal to 300 Kelvin. सही है. And 2 atmospheric pressure. Initial pressure का value है 2 atmosphere. वो भी सही है. It bursts suddenly. ये है ना? If you cannot understand what you mean by this, we cannot do anything with this problem. It bursts suddenly. The thing should come is like, this is a thermodynamic process which happens so fastly, zoom, right? If any thermodynamic process happens so fastly, there won't be any time for the system or surroundings to exchange the heat energy. मतलब delta Q का value 0 हो जाएगा for any sudden process. Or in simple words, any sudden process are what? Any sudden process are adiabatic. So here we are talking about an adiabatic process. Don't miss it. ठीक है. Then the resultant temperature will be, final temperature T2 is the question mark. देख ले, options are in degrees Celsius. So after you solve, you'll get the temperature in Kelvin. Don't forget to convert it degree Celsius पे. ठीक है. Formula क्या है? Okay. P1, T1 is given, ठीक है, and T2 is being asked. लेकिन sir, even though we are using the formula, P2 तो value we should be knowing. Anyone? Anyone? P2 का value किसका दिमाग में जलाया वो? P2 का value, final pressure once this particular tire burst. अरे once the tire is being burst, it is open to the atmosphere, right? Once it is open to the atmosphere, the pressure of the tire will be same as the pressure of the atmosphere. So the final pressure will be equal to atmospheric pressure, which is 1.01 into 10 power 5 Pascal. ठीक है, सही है, okay. Now we can apply. General formula क्या है? That we already know. P1 V1 raised to gamma is P2 V2 raised to gamma. Many of you will be knowing this only. We don't know the formula that connects pressure and temperature for an adiabatic. But hey, those who know this, that is more than enough. We just need to make the substitution. We know that PV equal to nR. We don't want volume in the equation, right? So we'll substitute for volume. nRT divided by P. N and R to constant hai. So we will write P1. V1 is equal to nR, let's say some constant, into T divided by P, the whole raised to gamma. P2 into V2, I can write it as some constant, write a temperature T2 into final pressure P2, the whole raised to gamma. सही है, constant though the sides it will get cancelled. Here we have T raised to gamma, P raised to gamma, this P1 will get cancelled, P1 raised to gamma minus 1. ये कितना है? T2 raised to gamma sir, और क्या है? P2 raised to gamma, here one more P2 cancel हो जाएगा, P2 raised to gamma minus 1. हो गई बात. If you know this, substitute कर ले and answer मिल जा. T1 का वैल्यू 300, ठीक है. P1 का वैल्यू 2 एटमोस्फियर. T2 रेज टू गामा, अरे T2 हमको पता नहीं. रेज टू गामा 1.22 है, सॉरी, गामा का वैल्यू इज 1.4, that is equal to 14 by 10, 5 by 7. Writing it as 5 by 7 is better. So here also 5 by 7 है, भूल गया. Okay, here 2 raised to 5 by 7, gamma minus 1. Gamma is 5 by 7. So 5 by 7 minus 1. 5 minus 7 minus... oh, 5 by 7. यार क्या कर रहे हैं सर आप? 7 by 5 है ना? 1.4 का मतलब ये कि 14 divided by 10, that is equal to 7 by 5. क्या कर रहे हैं साहब? ठीक है, so we'll substitute it as 7 by 5 here, ठीक है, 7 by 5 here, okay. P1 raised to gamma minus 1, that is 7 by 5 minus 1, that is 2 by 5. 2 raised to 2 by 5 divided by, देख ले, P2 raised to gamma. P2 का वैल्यू क्या है? P2 का वैल्यू क्या है? 1 atmosphere, right? We are doing it in atmosphere itself. So 1.01 into 10 power 5 Pascal is 1 atmosphere. So 1 raised to 2 by 5, 1 ही हो जाएगा. 1 raised to 2 by 5. अरे here is also in atmosphere, here also in atmosphere. So we don't need to make the conversion. Cancel हो जाएगा. ठीक है, cross multiply कर ले. ये 2 raised to हो जाएगा. Then 3 raised to 7 by 5, T2 raised to, okay, T2 raised to. Now removing 7 by 5 from here, we'll remove the 7 by 5 from here. This will be 300. ठीक है, so this will be 2 raised to 2 by 5 into 5 by 7. Right? Because we are removing the 7 by 5 from everywhere. So हो क्या हो जाएगा? 5 cancel, 2 by 7. 2 raised to 2 by 7 का value given in the question already, 1.22. So this T2 will be equal to 300 divided by 2 raised to 2 by 7, 1.22. कितना मिल जाएगा? This will be 246 Kelvin. Final temperature T2 246 Kelvin मिल जाएगा, but हमको नहीं चाहिए the temperature in Kelvin, right? हमको नहीं चाहिए in Kelvin. In which unit we want the temperature? We want in degrees Celsius. So 246 minus 273 कर ले, which will give you the answer as minus 27 degrees Celsius. मिल गया? अच्छा वाला क्वेश्चन है ये, ठीक है, अच्छा वाला क्वेश्चन है. I hope you all have noted this down and समझ में आ गया सब. बोल दो, आ गया तो आ गया, समझ तो आ गया सर. And tell me, sir, just go for the next question. We are just eagerly waiting for the next question. Shall I move to the next? Anaira, good afternoon. Good afternoon. समझ में नहीं आया. अरे इधर तो क्या किया? We just did the cross multiplication. I just removed the power. ये सब mathematics है. I didn't introduce anything from physics here. सब mathematics है. Everything is mathematics here. So final answer I got it in Kelvin. Converted Kelvin to degrees Celsius by subtracting 273. Right? We'll get it as minus 27 degrees Celsius. So हमारा final answer हो जाएगा option C. Okay. Next one. जल्दी से देख ले. If you have any doubts, you can ask me. Any doubts? I'll just look into the chat box once again. Okay, Mehrubia, bye bye. Okay, those questions which you're gonna miss, please do watch it after the class. Okay. Okay. I returned late from institute. No worries, Anaira. Join the class. Okay. Next one. Next question is here. Read it. Take your time. Understand how we are doing the problem. Now try to answer in your own way. And after some 15 to 20 seconds, I'll start explaining. In the meanwhile, also you can keep on giving me the answers. Do anybody have the answers already? किसी के पास आंसर है? Does anybody have answers? So Telegram link not working, maybe some glitches. Okay, some technical glitches. It will be okay soon. Don't worry, Shriya. No, you didn't get the answer, Abraham. No, Anaira is going for the option D there, which says 3 by 2. Option S, Mithilesh. Or A. Okay, option A. Okay. So, bacha log, those who haven't completed, keep on doing, keep on doing, keep on giving me the answers. Okay, those who want to listen can listen to me here. In an adiabatic process, the pressure and temperature relation is given as pressure is equal to K T raised to 5 by 2. A thermodynamic process is being represented in terms of pressure and temperature as such. So, question is, what is adiabatic constant gamma? So, for finding out this gamma, right, we should be writing the general formula for pressure and temperature for an adiabatic process. Compare that general equation with the already given equation. From there, we'll find gamma. Okay. Tell me, what is the general formula for pressure and temperature for an adiabatic process? Just now we have derived. How much is it? देख ले. T1 raised to gamma by P1 raised to gamma minus 1, or T raised to gamma by P raised to gamma minus 1 constant. How will you write? T raised to gamma by P raised to gamma minus 1 is some constant, right? Or you can write P raised to gamma minus 1 is equal to, ये ऊपर हो जाएगा, that is T raised to gamma by a constant. 1 by C will be another constant, so we'll write C dash is equal to T raised to gamma P raised to gamma minus 1. Divide the entire equation, right, to the power of 1 by gamma minus 1. Divide कर ले. 1 by gamma minus 1, 1 by gamma minus 1, 1 by gamma minus 1. हो क्या हो जाएगा? P raised to gamma minus 1 by gamma minus 1 is P. C raised to 1 by gamma minus 1 is another constant. Let us put it as K, right? So this will be T raised to gamma. So this is the general equation which represents an adiabatic process in terms of pressure and temperature. Compare this with the equation given. P is equal to P equal to constant, constant, temperature, temperature, raised to 5 by 2, raised to gamma minus 1. So this value of 5 by 2 is actually corresponding to what? Gamma raised to gamma minus 1. Usko kya ho gaya? Okay, so this 5 by 2 is corresponding to gamma raised to gamma minus 1. We are supposed to find gamma. Cross multiply kar le, mil jaye le, or get the answer. Cross 5 gamma minus 5, 2 gamma. 5 gamma minus 2 gamma is 3 gamma. Minus 5 plus 5. Gamma equal to 5 by 3. मिल गया या नहीं मिल गया? मिल गया या नहीं मिल गया? मिल गया. Simple. Right? नन्नू मुन्नू concept. सीधा साधा concept. Happy हो गया तो give me a smile in the chat box. If you're happy, give me a smile. How was my day, Preeti? Awesome. It's going good actually. I'm so happy everything is going good. So yes. Any doubt? Your chemistry exam was superb, I know that. ठीक है. All my bacha logs, all my super amazing students are super great. So all your exam is going to be wonderful. You will define it as super great, super amazing. I know that, right? And I'm so happy to be a part of it. Sir, please write in big size. इससे ज़्यादा? अरे ये तो सब समझ में आ रहा है. I can see what I'm writing in front of my screen also. अच्छे से दिख रहा है. Let me see. अरे बोर्ड पे भी अच्छे से दिख रहा है. मैथमेटिक्स हो जाएगा. ओके, नॉट अ बिग डील. मैथमेटिक्स में क्या है? ओके, हो जाएगा ऐसे. Okay, you just need to learn so many formulas out there, right? Which you all can do that. So just by heart and go and grab all your marks. So shall we proceed? Note bhi kiya Sumit? Awesome, awesome, awesome. So yes, let's proceed further. Next question is right, what we have it over here. Okay. Okay, we'll skip this question. Okay, you can do this as homework. We have done this kind of question many times. Okay, you can do this particular question as homework. Okay, before coming to next class, tell me whether you got the answer or not. Okay, fine. ये question कर लो. ये question कर ले मेरे बच्चा लोग. Everyone. नन्नू मुन्नू question है actually. It's a good question. Anyone? Mithilesh option D. Then Sumit D. Mithilesh. Then okay, good. Everyone can mark your answer jaldi se. Okay. So I'm getting a mix of options there. Very good. So yes, let's do this and let's see what is our final answer going to be. Have a look here. 2 kilogram of water is converted into steam. What is happening? Change of phase. Water becomes steam. Okay. By boiling at atmospheric pressure. Matlab, the entire time during the change of state, during the time of change of state, atmospheric constant, right? Matlab the pressure is remain or made as a constant there. Okay. The volume changes from initial volume, final volume. Initial is how much? 2 into 10 power minus 3. Final is 3.34. Fine. Work done by the system is about. So, what kind of a thermodynamic process it is? Entire process happens at the atmospheric pressure, which means pressure is remaining as a constant. If pressure is a constant, work done का formula क्या है मेरे बच्चे लोग? Pressure into final volume minus initial volume. Any doubt in this? If pressure is a constant, work done ka formula is P into V2 minus V1. Okay, start substituting. Atmospheric pressure is equal to 1.01 into 10 power 5. Okay, V2 minus V1. Final volume kya hai? 3.34. Right, minus 2 into 10 power minus 3. Initial volume is 2 into 10 power minus 3. Okay, so final minus initial 3.34 minus 2 into 10 power, array 2 into 10 power minus 3 nannu gunnu value. It will be like almost 2.34 itself or 2.3 let's say. Okay, so there won't be much changes here. That into 10 power 5 into 1.01. देख ले 3.34 into 1.01 will increase 3.34 by a total value. How much it will become? Almost let's say 3.4. Fine. Into 10 power 5, I'm going to write as 10 square into 10 power 3 joules. So this will be 340. 3.4 into 10 square into 10 power 3 joules is kilojoules. Option D मिल जाएगा. Right? Not much of calculation. The only thing that you have to understand is when in the question says the entire process happens at atmospheric pressure, this thought should come into your mind that pressure is a constant. Pressure is a constant, work done formula is this, substituting the values, we will get the answer. Because we know that for isothermal process, for adiabatic process, then for isobaric process where pressure is a constant, isochoric process where volume is a constant, for all these processes, work done ka value different. Right? The formula for calculation is totally different. So we have to understand what kind of thermodynamic process we are talking about. Based on that, we can use a formula ऐसे कर सकता है, हाँ कर सकता है, और substituting the values will get the answer. बस और कुछ भी नहीं. Okay. Yes. Awesome. All good. Munna, you look like Vijay. Alright, thank you. Simple dimple, right? Okay, awesome. Shall we proceed further? Any doubts, anyone? Any doubt? Anyone for this particular question? No, I suppose. So, simple dimple, Nannu Munnu question, right? So, yeah. Okay, my last class will be on Monday and I'll make my class at 8 p.m. Okay, I'll try to make my class at 8 p.m. Okay, so we'll proceed to the next. I hope you all have copy कर लिया है ना. अगला question कर ले. ये भी सही almost same है, लेकिन here the question is not to find the work done. Question is to find the increase in internal energy. Okay, same process happen. मतलब here also the change of phase is happening from water to vapor. In that case, question is to find internal energy change, not work done here. Obviously, you have to find work done for doing this. So anyway, try to figure out what you have to do and how to get the answer. मिल जाएगा, सब लोगों को मिल जाएगा. Not a big deal. Everyone, jaldi se. And those who got Anna, give me the answers here. Sumit is going for option A here, right? Very good. Mithilesh, very good. Anyone else? Anyone else? Anyone else? Okay, so let me solve it. Here we go. Okay, when 1 gram of water changes from liquid to vapor at constant pressure, okay, of 1 atmosphere, the volume increases from 1 centimeter cube to 1671 centimeter cube. देख ले, constant pressure thermodynamic process is what we are talking about. Okay, right. The heat of vaporization, latent heat of vaporization का value be given, increase in internal energy. कैसे? Simple. Delta Q का value we know, delta U plus work done. As this is an what kind of process? Constant pressure process or isobaric process, work done is P into V2 minus V1. That's it. Now just substituting for delta Q and pressure V2 minus V1, this unknown of delta U will be known to us. Let's do it. Delta Q, heat energy given. For what purpose? For change of state from water to vapor. What is the formula? That is equal to mass into latent heat of vaporization. Right? Okay, delta U plus P into P क्या है? P. अरे it happens at the constant pressure of atmosphere, 1 atmosphere. So pressure 1 atmosphere is equal to 1.01 into 10 power 5 Pascal. V2 final volume 1671 minus initial volume is 1. Here it's in centimeter cube. We'll have to convert into meter cube. कैसे? Multiplying it with 10 power minus 6. Okay. Now start substituting. Mass कितना है? 1 gram or 10 power minus 3. Latent heat of vaporization is 540. Right? And बच्चा लोग, you have to know that अरे, this is in calories per gram. So we don't need to make the conversion. We can write it as 1 gram itself. Okay, because latent heat of vaporization is 540 calories per gram. Okay. Now what we need to do is, it's in calories. The answer is in joules. We have to convert, right? We have to know that 1 calorie is equal to 4.18 joules. So 540 into 4.18 we have to multiply, because 1 calorie is 4.18. 540 calories is equal to 540 into 4.18 is equal to, how much is this? 1671 minus 11670. 10 power 5, 10 power minus 6 is 10 power minus 1. 10 power minus 1 into 1670 is 167. 167 into 1.01 is almost 169 plus delta U. Okay, 540 into 4.18 almost कितना आ जाएगा? We will be almost getting an answer of 2260, let's say. Okay, 2005, okay, yeah, 2260 minus 169 is delta U. Taking 169 to the left, 2100 मिल जाएगा almost. Okay, approximated value. Approximated delta U is equal to 2100. The value which is more close to. ठीक है, so वही है. समझ में आ गया तो बढ़िया बात है, खुशी का बात है, एंजॉय करने का वक्त है, राइट? सो इज इट क्लियर? इज द कॉन्सेप्ट क्लियर सबको? बोलो हाँ सर, हाँ बिल्कुल. एवरीवन जस्ट येल आउट. आई डोंट वांट द क्लास टू बी स्लीपिंग आउट देयर. अरे वाह प्रीति, वाह, व्हाट एन अमेजिंग लाइन. यादों की फ्रेम में आपकी तस्वीर सजाएंगा, आप तो जा रहे हैं पर हमें बहुत याद आएंगे. वाह बच्चा लोग, वाह. Simple dimple, right Mithilesh? Very good. Preeti, yes, clear? Awesome. Awesome, let's say super awesome. Any doubts? Have a look here. देख ले अच्छे से, कोई भी डाउट है तो बोल दे. आ गया समझ है ना, अच्छे से, नन्हे से प्यारे से मुन्ने से. Okay, I think we will move further, right? We'll proceed further. Okay, here we go to the next. Next question आ गया, जल्दी से कर ले everyone here. Try doing it. I'm expecting answers from as many as possible from here. You have so many shairis. Okay, save one for each day. Okay, Preeti. Mithilesh C, Munara C, Sumit C. Okay, let's do it. A prayer call is happening from the mosque. I'll be silent for 1 minute. Okay, until that is over. Thank you for understanding. So, anyone? Very sorry. Okay, we'll proceed. Right? Anyone already gave me the answer? Okay, let's get started. Here we go. In an isochoric process, isochoric matlab volume is a constant. If volume is a constant, we know that P1 by T1 का value होता है P2 by T2. है ना? In a volume constant process. So T1 and T2 का value is given, we need P1, P2. Rearrange कर ले. P1 by P2 is equal to T1 divided by T2. Right. What is temperature T1? We'll write it here itself. Temperature T1 is 27. Will we put it as 27? No. I've told you, I think, a million times. When we substitute temperature, it should be in Kelvin scale. Okay. So temperature T1 is equal to 27. How will you convert into Kelvin? By adding it with 273. By T2 is 127. Add 273 to it. How much हो जाएगा? 300 by 400, and that will be equal to 3 by 4. So P1 by P2 का value हो जाएगा 3 by 4. Fine. Which is our option then is going to be? It is option C we have here, which is 3 by 4. Any doubts, anyone? No, right? No, right? Okay. Once again, correct, Mithilesh. Very good, very good. Awesome. Let me send some water. Okay. I'm ready to catch the water. Okay. Simple dimple question, right? Very good, very good, very good. So if you're finding all these questions simple dimple, then it's awesome, which means the concepts are super clear to every one of you. That's what I have to get from here, right? So happy, simple dimple. Moving for the next one, I suppose. Shall I move to the next one? Okay, yes. The next question is right in front of us. We can start doing it. Start doing everyone. Jaldi. Okay, Mithilesh, very good option A. got the answer, right? डोलते हम सभी अस्मा बन गए, चांद का नुरले कहाँ से कहाँ गए, ऐसे सर को भला कैसे कर दे विधाता. Okay, so I'm not so this good in Hindi to understand this big Hindi, right? Anyway, I think you have written some good words about me. Anyway, thank you so much for that. We'll do this. 500 gram of water is heated from 30 degrees Celsius to 60 degrees Celsius. मतलब temperature तो बढ़ रहा है. The temperature is increasing for the body. Which body? Water. Okay. Ignoring the slight expansion of water. मतलब increase in volume of the body we are asked to ignore. मतलब they are asking to consider the change in volume as zero, or they are asking to say that okay, volume is remaining as a constant or change in volume is zero. Okay, fine. Calculate the change in internal energy of the water. Okay, how can we do this? It's actually very simple. I'll tell you here. देख ले डेल्टा यू का जीरो, डेल्टा वी वैल्यू जीरो, चेंज इन वॉल्यूम इज जीरो का मतलब ये कि वर्क डन जीरो है. Now, how can I get internal energy? From our first law of thermodynamics. Work done zero है, which means change in internal energy is equal to delta Q, which is the heat energy given. How can we calculate the heat energy for a body which increases its temperature? We all know the formula. Heat energy given as NS, that is specific heat capacity into change in temperature. Isn't it? We have learned this in thermal properties, right? So just use those concepts from thermal properties applied here. N, number of moles, right? Sorry, this is specific heat capacity, so it is ms delta T, not number of moles. Because if you are using molar heat capacity, you have to multiply number of moles. If this is specific heat capacity, we'll multiply it with mass. भूल गया मैं. ठीक है, mass कितना है? 500 grams or half kilogram, isn't it? That is half kilogram, 500 grams. Specific heat capacity of water, we should be knowing it by heart. Temperature is moving from 30 to 60. So change in temperature is 60 minus 30. That will be equal to change in internal energy. Now, if you do this, you will be getting this as 62.76 into 10 power 3 joules as change in internal energy. ठीक है, 62.76 into 10 power 3 joule will be 62.76 kilojoules, and there we have the option A as our correct answer. मिल गया तो मिल गया. Correct? Simple temple? Okay, all good. So, yes. Any doubt? Anyone? Any nannu munnu doubts? Koi bhi chotu motu doubts? No, I suppose, right? And let me tell you, that was the last question here. I'm also going to eat, Preeti, and that was the last question. We are done with the class for today. So I'm also running for the food here. I think my mom has made some delicious food for today for my lunch, which I haven't had till now, though it's 4:10. No doubts, right? Okay, good. Awesome. So we'll proceed further, mera chalo. You can, if anybody is having any doubts, you can keep on posting it. कुछ भी नहीं है तो fine. I'll give you some amazing opportunities to grab some scholarship. You all will be soon joining to the colleges, right? And there you know that you'll have to pay for your colleges, so many other things, laptops, sub. So if you want to get a scholarship whenever you join college, this is your best chance by being a part of Unacademy Prodigy program, right? So this next exam is going to happen on Feb 27, the scholarship test, and this will help you to grab a scholarship worth rupees almost 20 lakhs, and so many prizes is waiting for you. It happens on 12 to 1 p.m. and you can enroll to this course for free by using the code of AMP. Okay, fine. Great. Now moving on. So class 11 batch course details is given. You can join any of the courses and be a part of it and enjoy being a part of it. Okay. Now yes, moving on. Special class timetable I'll be soon updating you. Free special classes are filled with so many features with real you'll be having live chats, question tabs where you can ask all your doubts, then live polls and quizzes will be there, and leaderboards. All amazing things are waiting for you. Okay, now offers are going on, Marwa Chalo. If you go for 3 months subscription, 1 month will be given free only for the first 500 subscribers. Don't miss it. So yes, thank you so much. Very good, Mithilesh. Happy for you. Okay, so keep on solving more and more questions, Mithilesh. Okay. Yes, I'm so proud of you. Abhiram, nice session. Thank you so much. Okay, so I'm gonna leave every one of you right now. Okay, with a beautiful bye and with a beautiful good evening here in this classroom. So, shall I say? Okay, so thank you so much, everyone. Thank you so much, Siti. Okay, so bye bye, everyone. See you all in our next classes. Till then, bye bye, take care, and be in your good health always. And take care of yourself. Bye.